Hello friends, myself Meenakshi Dikshit, Senior Lecturer at Praveen Patil College of Diploma Engineering and Technology, Bhinder East, Thane. Today we are going to learn an important rule of numerical integration which is known as a trapezoidal rule. So let's start. Learning outcomes. After watching this video, student will understand the concept of numerical integration, able to apply the concept of trapezoidal rule and able to find area of irregular curves. Introduction. In mathematics and more specifically in numerical analysis, the trapezoidal rule, which is also known as a trapezoid rule or trapezium rule, is a technique for approximating the definite integral. The trapezoidal rule works by approximating the region under the graph of the function f of x as a trapezoid and calculating its area. Basics of the trapezoidal rule. So we all know that the area of a trapezium or trapezoid is given by the formula A is equal to h upon 2 a plus b, where a and b are length of the parallel side of trapezium and h is the height. By generalizing this, we get the actual diagram of graph of function f of x made up of trapezoids, and that will look like the given figure, like this. So the trapezoidal rule, we can summarize the trapezoidal rule as integral a to b f of x dx, which is approximately equal to b minus a into f of a plus f of b upon 2. That means trapezoidal rule is a technique of approximating the definite integral. So the trapezoidal rule approximates the area under the curve as a trapezoid with upper corners on the curve and determines the value for the interval using the area of the trapezoid formed, as you can see in this diagram. Now trapezoidal rule for uniform grid means when whole interval is divided into n equal parts. As you can see in the graph, interval a to b is divided into 4 equal parts: x0 to x1, x1 to x2, x2 to x3 and x3 to x4 with common difference h. So from this we can say that integral a to b f of x dx is equal to integral x0 to x1 f of x dx plus integral x1 to x2 f of x dx plus integral x2 to x3 f of x dx, so on. By taking h upon 2 common, we get h upon 2 into f of x0 plus f of x1 plus h upon 2 f of x1 plus f of x2 plus so on. Now by taking h upon 2 on common, we get h upon 2 into f of x0 plus f of plus 2 f of x1 plus 2 f of x2 plus so on. So we can summarize this formula as h upon 2 into, in bracket, write down the first value plus last value, first value plus last value plus 2 into remaining values, 2 into addition of remaining values. Now area covered by the trapezoids are slightly different from the area under the curve, as you can see in graph. This difference is known as a error. This is the actual graph. This red line shows the actual curve and this blue lines is a trapezoids, right? So as you can see here, area is excluded, right? Here extra area is included. So this gives the error. So next is error analysis. The accuracy will be measured by the calculated area is how close to the curve. The accuracy can be increased by using smaller intervals. So we can measure this error by formula. Error is equal to true value minus approximate value of integral. We can find the percentage of error by using formula error upon true value of integral into 100. Now on the basis of error, we get two types of calculated area, that are overestimates and underestimates. Now what is overestimate? So when the gradient of the graph is above or increasing over the actual curve, our calculated area is overestimated. See in this diagram also, the gradient is increasing or above the actual curve. So this is overestimated. Then underestimated. So when the gradient of the curve is below or ascending over the actual curve, then calculated area is underestimated. See in this diagram also, this is the actual curve and this is the gradient. So it is below the actual curve. So this is underestimated. So now let's see the example of trapezoidal rule. So example 1, use the trapezoidal rule with n equal to 8 to estimate integral 1 to 5, integral 1 plus x square dx. Here n is given as 8. So first we have to find h, means common difference, which is also denoted by delta x, and that is equal to upper limit minus lower limit divided by n. So 5 minus 1 upon 8. So 0.5. Now we have to prepare this xy table. So first find the x values. For x values, start from the lower limit value. Here lower limit value is 1. So first value will be 1. Then 1 plus h means 1 plus 0.5. So next value 1.5. Then 1.5 plus h. So 2. Then 2 plus h, 2.5. 2.5 plus 0.5, 3. Then 3 plus h, 3.5. 3.5 plus h, 4. 4 plus h, 4.5. 4.5 plus h, 5. After finding x values, next find y. Y is given function. So here function is under root of 1 plus x square. So y is under root of 1 plus x square. Now when x equal to 1, then y will be 1 plus 1 square. So root of 2. When x will be 1.5, then y will be under root of 1 plus 1.5 square. So that is under root of 3.25. When x will be 2, then y will be root of 1 plus 2 square. So under root of 5. Okay. So by substituting x values, we get the y values. After preparing this table, we apply the trapezoidal rule. So trapezoidal rule says that h upon 2 into first value plus last value plus 2 into addition of remaining values. This is the first value and this one is last value. Then plus 2 into addition of remaining values. So by doing this calculation, substituting the values in trapezoidal formula, we get answer as 12.76. Now let us see one more example. Here question is, use the trapezoidal rule to approximate integral 0 to pi sin x dx using n equal to 6 subintervals and n equal to 12 subintervals. Here A is lower limit. Lower limit is given as 0. B is upper limit. Upper limit is pi. And f of x is sin x. Now first one, by taking n equal to 6, first we have to find h. H will be upper limit minus lower limit divided by n. So h will be pi upon 6. Pi minus 0 upon 6. So pi upon 6. Then we have to prepare the table. So for table, first write the x values. X values start from the lower limit. So from 0, then 0 plus h, pi upon 6. Pi upon 6 plus pi upon 6. So 2 pi upon 6. Then again 2 pi upon 6 plus pi upon 6. So 3 pi upon 6. So on. Last value will be upper limit. Upper limit means pi. So 6 pi upon 6 is pi. Then as per x values we have to find fi values or y values. So when x is 0, then fi or y will be sin 0. When x is pi upon 6, then y will be sin pi upon 6. So on. Now, after preparing this table, we have to apply the trapezoidal rule. So, trapezoidal rule is h upon 2 into first value plus last value plus 2 into addition of remaining values. So, after doing this calculation, we get answer as 2.2954. Sorry, 1.9548. Now, second part, when n equal to 12, then h is b minus a upon n. That means pi minus 0 upon 12. So, pi upon 12. Again, we have to find x values and y values. So, that means we have to prepare this table. Again, start from lower limit. So, 0. Then 0 plus h, pi upon 12. Then pi upon 12 plus pi upon 12 will give you 2 pi upon 12. So on, we find the values of x. Last value will be 12 pi upon 12, means upper limit. Upper limit is pi. Then y values. So when x is 0, y will be sin 0. When x is pi upon 12, y will be sin pi upon 12. So on. Then trapezoidal formula h upon 2 into first value plus last value plus 2 into addition of remaining values, and we get answer as 1.9885. Now application. Application of trapezoidal rule are, trapezoidal rules are used to find the area of irregular shapes. It is also used to find the sectional area. It is applied in earthwork calculation. It is widely used to find the volume of earthwork. In civil engineering, trapezoidal rule has many applications, especially in surveying. To find the moment of inertia, we apply the trapezoidal rule. In naval architecture, for approximation of the area and volume enclosed by the curves and surfaces, we use trapezoidal rule. These are the some important applications of trapezoidal rule. So by this, I am ending my session. Thank you. Thank you very much.